this is your channel Sosanasa1 here on YouTube. I am an electromechanical engineer in Manuel Ferreira Sosa. Now I am going to explain in general how to use a digital multimeter like this. This is an intermediate digital multimeter which has most of the functions we need to perform electrical and electronic tests and also to perform electrical and electronic measurements. This device is very useful for us to be able to evaluate whether a device or an electrical or electronic element is working. For example, to know if this capacitor is good or not, I necessarily have to use the digital multimeter since the multimeter is going to measure the unit of microfarads, and based on the result that you give me and the result that we have here written on the surface, we can determine whether it is good or not. If the number on the screen and the number here are very different, and this tells me that the capacitor is damaged now. If the numbers are almost identical, the one on the screen and the one here, when I have the multimeter connected to the capacitor, that means that the capacitor is good. We can also use the multimeter to test this little switch. This is one of these switches that bring the lamps that go on the desk. Also the fans, a small switch, which in this case we are not going to measure, we are going to carry out a test. The difference between measurement and testing is that testing tells me whether something is good or not in measurement. We have to have some knowledge to compare the data, and with that information and knowledge they determine whether it's good or not, and it also depends on the way we choose here. This thing I have, as I told you, is a multimeter. This thing we have here. We're going to bring it a little closer here. This is the mode selector. This selector here moves clockwise and counterclockwise. Each time it scrolls, it chooses a mode or chooses a maximum limit to measure within that mode. As we see the letters that he tells me here, and the numbers indicate something different, these letters in capital letters. For example, here it tells me that it measures current in amperes, but this is direct current. That is the current that comes, for example, from this battery I can measure by choosing here. Now how? I know the numbers that belong to this good mode are the ones that have the same color. For example, 20 amps, 200 milliamps, 20 milliamps. As we can see, the highest number is 20. Therefore, if we do not know which one to choose, always choose the highest number as the limit to measure within the current mode. Here we have the farad mode, which is the mode that is chosen when we want to measure farads or microfarads of a capacitor like this. This is a fan capacitor, so if I want to know if it is good or not, I can't do it by looking at it like this. It's simply impossible in my hands. This capacitor may be good or it may be damaged, and I don't know. The only way is to use the multimeter. By choosing this mode ranges from 20 nanofarads to 200 microfarads. The highest number here is 200 microfarads and the smallest is this. What indicates each number of these is that it is going to measure from 0 to the number we choose. For example, if I choose 2 microfarads, it will measure from 0 to 2. If I choose 200 microfarads, will choose from 0 to 200 microfarads, and so also applies to the other modes. Here we have the mode to test 1.5 volt batteries like this one that I showed you here. A battery like this tells you what level of charge it has left just by plugging it in. Here we have to test light emitting diodes. We see here the LED symbol and the continuity symbol, a point with several waves like we see here. So here what we're left with is this. This is the symbol for ohms. The ohm unit that is used to verify the condition of an electrical resistance. What is an electrical resistor? Look at her. Here, this I have here. Let's see. Let's see if the camera achieves it there. This is an electrical resistance. This I have here. This is used electronically to reduce the amount of current per line of a circuit. Electronic. Okay, so this mode is a little broader. As we see, this mode goes from 200 ohms to 2000 ohms. How do we see? M means millions, K means thousands. For example, 2000 is the same as saying 200 kilo. Is 200 kilo ohms the same as saying 200,000 ohms or 200 mega ohms? It's the same as saying 1000 ohms. Here the smallest number is 200 and the largest number is this. Something important is that if we do not know the value of the resistance, in this case it is not a good idea to set it to a number that is too large like this, since the multimedia will not detect anything. In this case, the correct thing is to set it at 2000 ohms or 20,000 ohms, or failing that 2 kilo ohms or 20 kilo ohms. Okay, so we continue in a few moments. We're going to test some modes so you can see how the multiple is used here. So this HFE, this unit is used for transistor testing. I connect the transistor here. Depending on its configuration, if it's NP, N, or if it's PN, this is a little more advanced. I enter the 3 lines of the transistor here or here, depending on its configuration, and choose this mode, and this way I can verify using the screen data whether the transistor is good or not. Well, then here we have the voltages, here we have voltage. In direct current, this symbol is for voltage in direct current. This is the voltage that comes from batteries like this one that I have in my hand. Batteries like the vehicle battery, the battery, for example, of a radio flashlight, etc. All of that contains what is direct current voltage. It is said direct because it comes from the same source at which it is measured. This mode ranges from 200 millivolts to 1000 volts. If unsure of the voltage to choose, always opt for the highest limit within the mode, here 1000 volts. We see what is AC voltage, generated far away, maybe hundreds or thousands of miles away, like in a house outlet. It's not close to us, it could be hundreds or thousands of miles away. This is the voltage that we find, for example, at an outlet in the house, for example. I mean an outlet like this. To measure the voltage of this outlet, we necessarily need to choose the AC voltage mode here. So this mode goes from 200 millivolts to a maximum of 750 volts, as we see here. If you don't know what voltage to choose, always choose the highest voltage. How do I choose it? Well, moving the selector, if I move this selector, the multimeter will automatically turn on. Well, here we go to the way of measuring alternating current, which measures from 20 millivolts to 20 volts, as we see. This alternating current is the same that comes from this outlet, but to measure it, the multimeter cannot be connected directly to the outlet. There has to be something that consumes current, and the multimeter is put on one of the lines that is powering that electrical device that is consuming current to measure how much current they consume now. To turn on the multimeter, what I do is here on the selector that I move it since I move it. Choosing anyway, and the screen tells me what we see on the screen. Well, we see 2 very important things, these big numbers. What it is going to tell me is the numerical value of what we are measuring, whether it is current, voltage, resistance, etc. And what this small number tells me is the limit that I set here for the multimeter to measure voltage. Let's see, for example. If I choose here, look at 200 kiloohms, 200 will appear on the screen, telling me that that is the measurement limit of electrical resistance in ohms. How do we see if I lower it, for example, Look, I put it at 20, here I get 20. That's just a reminder. So to use the multimeter, we are now going to use it to perform 3 small tests. The tests that we are going to carry out now are how to measure a capacitor to know if it is good, how to measure an electrical resistance to know if it is good, and a continuity test with a good interrupt for the capacitor, that is the first. Here I have 2 capacitors. Let's take this one for example, and the first step is to just read. Let's see, there we read. Let's read here. It says 4 microfarads. That's the number I need to get on the multimeter display to know this capacitor is good. 4 microfarads. Okay, I got it there. We are now going to configure the multimeter with that data. And I know here what the limit is that I am going to configure. In this case, we see here 2 microfarads and 200 microfarads, but the value I read on the capacitor is 4. That means I can't put 2 as the limit since 2 is less than 4. I have to choose the next level, which is 200 microfarads for that. I take the mode selector and put 200 there. As we can see, there I have 200 and here I also have it configured. Now, the multimeter is already set up down here. The test tips that are these with this is that we connect any electrical or electronic device to the multimeter to obtain information based on the mode we choose. So depending on which way I choose, here I'm going to connect this. The black tip, as we see, the black is the negative and the red is the positive. These colors only make sense when we measure voltage in direct current. If we measure voltage in alternating current, or we measure current in amperes or milliamperes. Or we choose electrical resistance, etc. They have no value. These colors only serve as positive and negative when we measure battery voltage. The battery, now the black one, which in this case I'm going to say because of the color, the black connector on the black tip is the common one. It always goes there, that one doesn't move. But to measure faradio, which is a capacitor, we have to change this red connector here where it says milliamperes, because here it says CX. That is capacitor test. I disconnect it from there and connect it there. So in this way I have already configured the mode and I have correctly connected the tips so that the multimeter understands and reads the value of the capacitor. As the multimeter will detect the capacitor well by connecting the test leads to the capacitor. One important thing is that they have to discharge the capacitor first to discharge it. What we do is that the 2 tips of the capacitor touch it like this, never touch this line or it is not discharged. Since this capacitor, for example, tells me that it can store up to 250 volts at high current inside. With that voltage, a person's heart can very easily stop and they can lose their life. Therefore, for safety, they should always discharge the capacitor, either by connecting something that consumes energy here or by shorting it here. If the capacitor is charged and you connect it like this, it will produce a small spark. Okay, now it's safe to play it very well, so now what I'm going to do is the following. Okay, now what I'm going to do is use these little tips. These are accessories that the multimeter sometimes includes. It doesn't always include it, These tips are to be able to hold, in this case, the capacitor, without my hands touching it, because when my hands touch it, they can alter the reading. Therefore, it is advisable to use this small accessory that are tweezers. And we do the following. Look to perform the test. What I'm going to do is hold one side here very well and now hold the other side. Here very well, and now I bring the digital multimeter closer to see the value. In this case, this capacitor has 3.4 microfarads. As we see on its surface, it must have 4 microfarads. We can say in this case that the capacitor is good, but it is no longer in very good condition. It would be better to say that this capacitor is damaged. It could work, but it is not in its best condition, since the value that has to be on the screen should be 3.6, 3.7, 3.8, 3.9 or 4. But 3.3 is a very low value. That means it is very deteriorated, and therefore this capacitor is damaged in this way. We can try a small capacitor. I'm going to disconnect it very well. Now I disconnect it. Now we're going to do a little continuity test. The continuity test is very easy. I look for the continuity test mode here. It is here, as we see here, perfect. So I choose it. Very well, in this mode, this little red bulb is going to light up. The multimeter is going to make a sound, and it's going to show me numbers. This will tell me that there is continuity. Continuity means that the red tip and the black tip are in contact with each other. There is a short circuit, that is, there is continuity. The energy is continuing from one tip to another. Look, as we see, nothing happened. You know why nothing happens? Because we need to reconnect this red tip here to where it was originally, since all the other modes other than the capacitor work when we connect the red tip here and the black tip here. Now let's see what happens. Look how we see it shows me numbers, turns on the red light bulb and rings. Does that mean there's continuity? Why supply this? Good for testing a switch. Because what an electrical switch does is cut off continuity and allow continuity. Therefore, everything that turns on or off electrically works continuously or without continuity. So what I do is I introduce one side here, I introduce the other side here. Let's see here, look, there is continuity, there is no, there yes. That means there it is on, there it is off in Spanish, and there it is on, and there it is off. This way we can test switches. Breakers, that is, anything that cuts off power and then allows power to flow, is tested with continuity. Well, now I only need to measure the electrical resistance to test one of the modes. In this case, the electrical resistance is fungi. Here I have a small electrical resistance, but I have a small problem. I don't know the value of that resistance. In this case, since I don't know the value, I'm going to choose here at least 2000 ohms, or 2 kiloohms, 2 kiloohms there. It is here, it tells me then that I have chosen 2 kiloohms, but look, where it puts 2, it puts it right where 1 is and then a dot. That's to tell me that it's 2000 ohms, that's why it puts it under me. No, it puts it on this side very well. Now the multimeter is configured. What I'm gonna do now is play. Look, I touch here, let's see if we can see well here or what we are seeing there. Look, we touch it there and we touch it there, and now we see the courage there. In this case, we have a value of 1000 here. Ohms or 1 kilo ohms. What does it mean that this resistance is 1 kilo ohms? How do we see, or a little less, because you see that they remain between 1000 and 999, it means that it can be from 980 to 970. That's why the number varies a little there. But here we see that this resistor has a value of 1 kilo ohms. Something important is that electrical resistors have no polarity. What I mean by this is this. Look, here I have it connected again. I'm going to invert it now. I'm going to turn this over and I'm going to connect it again. And as we see, the value on the digital multimeter screen is still positive because there is no positive or negative here. No matter how you connect the resistance to the tip of the multimeter, the value on the screen will always be positive, and this way you can use a digital multimeter like this to measure and test electrical resistance. This resistor is good. How do we know when an electrical resistor is damaged? When they connect it and the multimeter shows you no value, when it shows you no value. Either the number size is misconfigured or the resistor is damaged. How do we test it? We increase the value until it shows me. If it doesn't show me data, is it damaged then? In this way, this digital multimeter is used in general in the different modes it has to turn it off. I put it in the center and so I turn it off and so on. This is your channel, so Sanasa1, please give me a like. If you enjoyed this video, feel free to share it with everyone whom you believe will find it helpful. Should you have any questions, kindly leave them in the comments section. Share this video and thank you immensely for watching. Up next are some extremely important messages for you.
Subscribe to our channel Sanasa1 in English and activate the notification bell to receive the notification every Saturday of new videos.